Welcome. This lecture is about the driveline, that is, the connection between the engine and the wheels. The driveline consists of several parts and is sometimes also referred to as the transmission system, a number of parts transmitting speed and torque produced by the engine to the wheels. In this figure, you can see the entire powertrain of a truck. If we take away the engine, the remaining parts is the driveline. In this lecture, we will briefly talk about three components: the clutch, which is between the engine and gearbox, the gearbox, which changes speed and torque coming from the engine to the values desired by the vehicle, and the differential and final gear, which is dividing the torque and speed from the gearbox to the wheels. The first component is the clutch. This component connects or disconnects the engine and the gearbox. It is often referred to as an engaged or disengaged clutch. There are several types of designs, but here is only mentioned two: the mechanical and the hydraulic clutch. The mechanical clutch, when engaged, has no slip, so the shaft from the engine will have the same speed as the shaft going from the clutch to the gearbox. When disengaged, the outgoing shaft will transmit no engine torque. The hydraulic clutch always have a slip between the shafts in and out, and one consequence is that some energy is lost in this clutch. The next component is the gearbox. A person at a truck company once described the engine as the heart and the gearbox as the brain. What he meant, in my interpretation, is that the engine provides the work for propulsion, but the gearbox makes it possible to do it in a smart way. The purpose of the gearbox is to match the rotational speed and traction force needed by the vehicle to operational points suitable for the engine. The gearbox is a very complex component, but we will try to, through some simple steps, show what is going on inside the gearbox. There are several different types of gearboxes, and some are the manual gearbox, where the driver decides when to go from one gear to another, and the automatic gearbox, where the decision to change gear is made by the gearbox. Both these kinds of gearboxes have certain discrete values of how much the rotational speed is changed, which means that only discrete values of torque and speed is possible for the engine. And then we have the CVT, the continuously variable transmission, where it is possible to freely vary the change of rotational speed. But the focus in this lecture is the first kind, with discrete gearings. In the figure, you can see what happens when you connect two gear wheels. Looking at this, you realize that the change in rotational speed is given by how many teeth there are on the different wheels. If you count the number of teeth on the red gear and compare with the number of teeth on the blue gear, you realize that when the red wheel has rotated one revolution, the blue wheel have only rotated half a revolution. The change in speed is given as a speed ratio or gear ratio, denoted I. And if speed is given as angular speed, omega, the change in speed going from gear 1 to gear 2 is given by the first equation on the slide. Now, if you assume that there are no losses in the gear contact, power in is the same as power out. And remember that power is the product of angular speed and torque, so torque is changed as given by the last equation on the slide. But remember that in the real case there are losses. This will not change the transferred angular speed, but you lose some torque. And here is an exercise for you with some questions. You click next to go to the page where you enter your answers.